Okay,
Recording has started.
so what we're going to look at today is we're going to look at something that is specific for construction. I'm going to have you pull out your small book and turn to page 110. That's Unit 23. And we're going to talk about some of the things that can be done with your carpenter square, your framing square. So obviously your framing square, shaped like a big L. I exaggerated it a little bit. But you have the body of the framing square, the main portion of the framing square is that big part. Then the little piece sticking out is called the tongue. Now the tongue just has numbers, but it's useful. We'll show you how that's used, but it's the body that we really want to concentrate on today. We're looking at the words more specifically that are on the body. Look at the bottom of page 110. I realize most of you don't have your square in front of you, but on the bottom of page 110, they've got a nice blow up of it. Starting out at the end, at the higher measurements, I should say. The top line says length, common rafter per foot.
Recording is on.
Run. Well, it's very choppy English, but that is what that is saying is length of the common rafter per foot of run. That's saying, oops, we got somebody came in. You got your microphone on. I can have you mute that for me so we're not getting so much background noise. So, what is that doing? How do we use that? Well, you'll notice up along the top there are the numbers, the measurements, and it starts at like 23 here. 24, of course, would be at the very end. It starts 23, 22, and going on down. Well, there's no numbers for those, but starting at 18, there's a column of numbers. And the top number under the 18 is 2163. Now, they don't put the decimal point in there, but that really means 21.63. So what that is saying is for a common rafter. Now, a common rafter is just simply you have a run, you have a rise, the common rafter goes across there like that. What this is saying is if this is an 18 and 12 slope, that's why we're looking under the 18 there, that if this is an 18 and 12 slope, for every 1 foot of run, there is going to be 22.63 inches, or 21, I should say, 0.63 inches of length on that common rafter. So I can actually use that to find how long the common rafter is going to be. Let's say I have a run. Let's say I'm going to have a run of 12 feet here. And let's say that this is let's do a 15 and 12 slope. So you go over to the number 15 on the top there and you follow it down. Underneath 15, it is 19.21. Again, they have 19 with a big space 2-1, but I'm going to put in the decimal point just to make it fit in a little smaller there. So the length of that common rafter here is just that run of 12 times the 19.21. Now you'll notice the 12 is in feet, but the 19.21 is inches per foot. So we get 230.52 inches. So our common rafter will be 230.52 inches long. Now we got to break that down. We don't want to leave it like that. So we're going to do, in our calculator, I've got 230.52. Now I'm going to go through this very slow the first time. This is in inches. I want it in feet, inches, and sixteenths. So to get that to feet, I divide by 12. So it's 19.21 feet. Well, that makes sense. It was 19.21 inches per foot, and there's 12 feet. All I want off of that is the 19. I'm going to write down the 19 feet. Now I've used the 19 feet. I'm going to subtract the 19 feet off of that. I'm left with 0.21. That's still feet. I need to take it back to inches. So I'm going to multiply by 12 to turn it back into inches. So I have 2.52 inches. That means I have 2 whole inches. I've written down the inches, so I'm going to subtract off the 2 whole inches. The 0.52 has to be converted to sixteenths. To do that, I'm simply going to multiply it by 16. 8.32 is 8 sixteenths. So that length is 19 foot. 8 sixteenths reduces to a half inch, so 2.5 inches. So on a 15-12 slope, a 12-foot run, that common rafter is going to be 19 feet, 2.5 inches. Well, the next row says length of hip or valley. Those little quotes just mean repeating the same words of above. So the length of the hip or valley per foot of run. Underneath the 18, that is 24.74. Again, the decimal point isn't written, but it's implied that it's in there. So what that is saying is if you have a hip rafter or a valley rafter, so if I have 2 roofs that come together, and the stuff that's on the framing square only works if it's what we call conventional. So let's say it's 24 feet. Well, let's use numbers that don't work quite so neatly. 28 feet on both sides here. So our peaks come up. We have a valley there. The run of that valley is actually considered to be 14 feet. That's half of the 28. It's 14 feet in both directions. So because it's 14 feet in both directions, then we can use this to find the length of that valley rafter. And let's say that this is an 1812 slope. So it's an 1812 slope. We take that number, 24.74, and we're going to multiply it by that run of 14 feet. Now again, the 14 might be in inches, but our answer here is going to be in, so the 14 feet might be in feet, but our answer here is going to be in inches. That's 346.36. Well, once again, we need to convert that back into feet, inches, and sixteenths. So I would highly recommend you write this process down. We start out on our calculator, 346.36. Convert that back into feet. I'm going to divide by 12. I got 28.863333. All I care about there is the 28 feet. But be very careful not to clear the calculator because we need the rest of it here in a little bit. So I took the 28 feet, so I'm just going to subtract 28 feet. I got 28 whole feet out of that. The decimal portion there has to be turned back into inches. Now you do have to be very careful not to write this down and type it back in. If you do that, you're going to lose a lot in the round off. I'm going to multiply by 12 to turn that back into inches. I get 10.36. That's 10 whole inches. All I did was I took the part in front of the decimal point. So now I'm going to subtract off that 10. The 0.36 inches I want to turn into sixteenths. So times 16 is 5.76. That's 6. 5.76 is closer to 6 than it is to 5. That's 6/16 of an inch. That's 28 feet. 10 6/16 reduces to 3/8 inches. So that's how long that rafter going up that hip would be. That hip, or not hip, that valley rafter would have to be. Our next line's up there. It says difference in length of jacks for 16-inch centers. Well, have you guys covered what jacks are yet? No? In a valley like this, the green rafters here are the common rafters, and they go down the roof in both directions away from the valley. The blue one that I drew in blue is the valley rafter. It goes right up the middle of the valley. The jacks are always parallel to the common rafters, but they're the ones that are shorter, that are butt up against that valley rafter. The thing with those jacks is the difference from the common rafter to the first jack is the same as the difference in length from the first jack to the second, same as the difference from the second to the third. That's a common difference in length. So we can just keep cutting the same amount off of each one to get to the next one. And again, what it's saying there is for 1812, we're going to go with again. This is for 16-inch on center. It's 28 7/8. It's strange that it flops back and forth from decimals to fractions like that. And it's not consistent from one framing square to another. Some framing squares do keep it all in decimals. This one does flop back and forth, and a lot of them do. So 28 7/8 inches per is the difference. So if these rafters are spaced 16 inches apart, the difference in length from this common rafter to that first jack, you would subtract 28 7/8 inches off of it. Then the next one is the difference in length of jacks, 24-inch or 2 foot on center, depending on this one's listed 2 foot on center. Means the same thing. Well, obviously, if they're further apart, their difference in length is going to be a little bit more. That one comes out to be 43 1/4 inches. Now, the next ones down are they call the side cut. The side cut is actually the angle when you put your jacks. The jacks go up against that valley. You have your valley rafter, your jacks coming up against it. There's an angle cut there. A lot of people think it's 45 degrees. It is not 45 degrees. So that is the last two lines there describe how to do the angle cut. We're not going to get into that. That's actually kind of complex on how that works. So we're going to be using mostly that top line today, the length of the common rafter per foot of run. If you look over to page 111 there, it shows a more useful section of that body of the framing square going from 12 down to 5, that's where most of our common roof slopes are, is between 412 and 1212 in slope. So let's say we have 512 slope. That's what that symbol means, that this is a 512 slope with a 36-foot run or span. Now, first of all, what's on the framing square is not per foot of span, it's per foot of run. The run is just the portion that goes underneath the slope that we're looking at. So this is the run, which is going to be 18 feet. Generally, in a common truss, it's always half the span, or a common rafter. So to find the length of the common rafter, which is this length right here. The run is 18 feet. We're going to look up under 512. That top number is just a 13. It's exactly 13. We have 18 times 13 gives us 234 inches. So I need to convert that into feet and inches. So I take my 234, I'm going to divide by 12. That's 19.5 feet. So that's 19 feet. I'm going to subtract the 19 that I just wrote down. And then the 0.5, I'm going to multiply by 12 to make it back into inches. So that's 6 inches. That's 19 feet, 6 inches. In your notes, I want you to find the length of each common rafter. So for number 1, we have a slope of 6/12. So that's a slope of 6 is what you would read. And a run 20 feet. Number 2, slope of 8/12. Span 28 feet. Number 3 is slope of 10/12 and a run of 18 feet. Try those 3 in your notes, see what you come up with, and we'll go over them in just about 2 minutes. Let's see how you're doing on these. So for 6/12 slope, so we look up on the framing square. Under the 6, it is 13.42. We multiply that, a run of 20 feet, so we're just going to multiply that times the 20 feet. 13.42 times 20. 268.4 inches. If I'm going to convert that to feet, inches, and sixteenths, I divide by 12 to make it back into feet. That's 22 feet. Subtract off the 22, turn it back into inches. By multiplying by 12, I got 4.4 inches, so that's 4 inches. Subtract off the 4 inches, I take that 0.4 times 16, which is 6.4, so that's 6/16, which will reduce to 3/8. 22 feet, 4 3/8 inches. For the second one, I gave you that the span is 28 feet. If the span is 28 feet, what's the run? The run will be half the span, 14 feet. So it'll be 14 feet times our number for 812. Under 8 it is 14.42. So 14 times 14.42 gives us 201.88 inches. We'll convert that into feet, inches, and sixteenths. So we divide by 12 to turn it back into feet. That's 16 feet. Subtract off the 16. Take our 0.82 feet back into inches, so multiply by 12. We got 9.88 inches. Subtract off the 9 whole inches. And then we'll do times 16 to get sixteenths. 14 sixteenths, which is 7/8. So 16 foot 9 7/8 inches is the length of that common rafter. For the last one there, 1012 slope. 1012 is 15.62. My light's a little lighter. It is 15.62. So it's an 18-foot run, so we are just going to use 18 times 15.62. 281.16 inches. Here. So we're going to divide by 12 to get our feet. That's 23 feet. Subtract off the 23. Multiply that decimal by 12 to get it back into inches. That's 5.16 inches. 5 inches. Subtract off the 5 whole inches. Times 16 to get sixteenths is 2.5. That's 3 sixteenths. 23 feet, 5 3/16 inches. Anybody have any questions on what I just did there? Good. Well, now the last thing I want to talk about for the day is the difference between slope and pitch. These are two words that are commonly misused. You might say, somebody says it's a 412 pitch on that house. No, it's not. It's a 412 slope. Both of them have to do with a roof. And both of them are describing how steep the roof is. Let's say that this is 24 feet. Let's say both of them are 24 feet. And this rise is 6 feet in both of them. The slope is rise over run. It's always given out of a run of 12. So here our run is 12 feet. So we have a rise of 6 over a run of 12. Pitch is always height over span. So here the height is still 6, but the span is the full 24. That's a 6 and 24, what reduces to a 1/4 pitch. Well, how do we convert from one to the other? If we know the pitch, want to convert to a slope. Let's say I have a 1/3 pitch. Convert that pitch to a slope. I take the 1/3 and I multiply by 24. What is 1/3 times 24? It's 8. That is an 8/12 slope. if I have a 1/6 pitch, I take 1/6 times 24. What's 1/6 times 24? That's 4. That's a 4/12 slope. What if I have the slope and want to convert it into a pitch? Well, let's say I know that it is a 6/12 slope, and I want to convert it into a pitch. It's actually really simple. Multiply it by 1/2. 6/12 times 1/2, well, 6 times 1 is 6, 12 times 2 is 24. Basically, all I'm doing is turning the 12 into a 24 every time. And then I reduce it. Both of those can be divided by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. A 6/12 slope is a 1/4 pitch. Oh, what if we have a 10/12 slope? Well, we take our 10/12 times 1/2, gives us 10 over 24, and then we reduce it. Both of those can be divided by 2, gives me a 5/12 pitch. That one's kind of confusing because it looks like a slope because it's over 12, but it's not. It's actually a pitch. So in your notes, I want you to convert these to slopes. A 1/2 pitch and a 2/3 pitch. We'll go over them in a minute. So, to change a pitch into the slope, all we do is we take the pitch times 24. 1/2 times 24 is 12. So that is a 12/12 slope. Two-thirds pitch, so we take 2/3 times 24. 2/3 times 24 is 16. That is a 16/12 slope. Any questions on that? Good, well, let's convert some slopes back into pitches. Let's see, a 4/12 slope, 6/12 slope, and let's do an 18/12 slope. Convert those and we'll go over them in just a minute. Okay, so for the first one, a 412 slope. So times 1/2 makes that 4 over 24. We reduce that, both those numbers divide by 4. It's a 1/6 pitch. .612 slope times 1/2 gives us 6 over 24. To reduce that, both of those can be divided by 6, giving us a 1/4 pitch. .1812 slope. Again, we multiply by 1/2. Gives us 18 over 24. Both of those can be divided by 6, giving us a 3/4 pitch. Any questions? Okay, so what I want you to do then is in a little book, Unit 23, I want you to do all of them, not just the odds here. There's only 8 problems in that whole section. I'll let you guys have our last 15 minutes to do those. We'll be on the network here if you have any questions.